everyone. We are very excited today because this is the third of our webinar series, but also today we are launching the Black Sea Digital Twin Ocean Demonstrator. And we are also very excited that there were more than 190 registrants. There was huge interest, so it's really we appreciate having you all here, seeing you today. And as I said, today's webinar series is the third of our webinar series. The first one, as you may remember, was on the blue economy, and the scenarios were described there, the blue economy scenarios. The second webinar was on technologies for smart monitoring. Again, another very successful seminar we have carried out. And today, the third and the last seminar is on the Bridge Black Sea Digital Twin Ocean demonstrator. And I will start with a brief introduction, so around 15 minutes. And at the end, I will show you the teaser of the demonstrator, just a 1-minute teaser. So to make sure that you all stay until the end and listen to the full demonstration and launch at the end. But before that, each component of the DTO demonstrator will be explained by the panelists here. The first one will be on the modeling engine framework, second one on adaptive management modules, AI-based emulator, resilience analysis, and then the blue economy observatories. And as I said, afterwards we'll launch the demonstrator, and then it will be explained to you by Ali. At the end, there will be time for discussions and questions. So, as you may know, Black Sea is one of the unique basins that has undergone through many stressors during the course of the last 5 decades. So there are many challenges related to the Black Sea. Understanding the effect of these different stressors, analyzing them, understanding how they affect different ecosystem services is really a big challenge. But on the other hand, there are many opportunities towards research. So for these reasons, we have started the Bridge Black Sea project around 4.5 years ago. So Bridge project is coming to an end. And this project has been carried out by 31 partners from 16 different countries. So everything I'm presenting here today at the end was built up by the contribution of all these valuable partners, both from the Black Sea region and from different parts of Europe. And I should also emphasize that when we have started this project at that time, there were no DTO calls. But I will tell you how we have structured at the end Bridge, so it's contributing to the Black Sea DTO. So the main goal of Bridge is to define and understand a safe operating space for the Black Sea. So again, for the first time, we have analyzed all the ecosystem services and developed solutions towards sustainable utilization of these services. While doing that, we have developed ecosystem-based management frameworks that enables policy uptake and foster citizen engagement. Again, today we have many colleagues from the European Commission and from national institutions that contribute to policy making and decision making. So it's really important to see them. If you go on the Bridge webpage, you will see that we have a both basin approach and a pilot sites approach. So at the moment, we have already defined the key ecosystem services and the main multi-stressors that are acting on these services and analyze them both at the basin scale level, but also at the pilot scale level. So this will be explained in more detail, but here you see the different ecosystem services that we have addressed with models. The climate regulation, ecosystem regulation, food provisioning, and recreational services, they all are addressed by models and afterwards by decision support tools. So when you look at how the results of the Bridge Black Sea, the DTO today that I'm presenting to you was a true co-creation process. We had 4 rounds of living labs that are established in all the pilot sites. We had many science policy events, and at the end of the project, a policy brief and a roadmap is being published. So if you come to the final conference or after the final conference, you can access these. And the Blue Economy Network in the Black Sea was not only limited with living labs, but also the Black Sea Accelerator Program, 2 high-tech summits included many different levels of stakeholders, which we have benefited from their inputs while establishing the DTO. And training and capacity building, as well as bridging science to society, were at the core of the Bridge Black Sea project. In terms of the knowledge base for the Black Sea, we were very well aware of that. We were limited with knowledge in the Black Sea. So to achieve that, we have carried out many efforts towards gathering critical data for the Black Sea, established a database, established a Blue Economy Observatory, and produced different scenarios, both based on our research, but also input from different stakeholders. And when it comes to understanding the safe operating space, we had different modules developed towards addressing this. One of them is the ensemble modeling framework. The other one is the resilience assessment, risk-based cumulative effect assessment, and AI-based emulator. These are beyond the core modules of the DTO demonstrator, are part of the DTO demonstrator already. So these are the innovative aspects that are supporting the Black Sea DTO towards addressing the safe operating space. And these will be detailed during the panel by our work package leaders. Black Sea DTO is a true digital twin ocean demonstrator that addresses almost all aspects what a DTO should be. So what do we do with the DTO, and why do we need a digital twin ocean demonstrator? First of all, a DTO is a virtual interaction between physical, chemical, and biological properties of the oceans. And it requires strong data sources and benefits from data lakes, observations, and even data assimilation. And it integrates AI-driven analysis tools and even an emulator for on-demand analysis. And it requires new ways of interaction and presentation of data. Interoperability and standardization are the key aspects, and developing what-if scenarios with the end users and modeling them for decision-making is the end product. It should be the end product or one of the end products of a digital twin ocean demonstrator. So you need to include the ocean observations, you need to address the biodiversity, human activities, different ocean models, develop predictions, especially the effects of climate change, and develop what-if scenarios towards, for example, marine spatial planning and MSFD assessment. So when it comes to the Bridge BSDTO structure, what you see on the left are the core modules, the data, coupled ensemble models, sectoral stakeholder inputs, and the portal. In the middle, these key components, they feed for the Black Sea DTO structure, the decision support tools, risk-based cumulative effect analysis, resilience assessment, and the AI modulator. So you need all these different modules to truly address the safe operating space and the planetary boundaries and the boundaries of the ecosystem in a sea. And Bridge developed several use cases and different what-if scenarios within these use cases. These scenarios include climate change, fish-related scenarios, plastic, nutrient, and different desired scenarios are also developed within the Bridge project, which was the topic of the first webinar. And what was the problem landscape when we have started this? As I told you, when we have started, there was no requirement towards developing and contributing to the DTO system or the editor system. But as you have seen in the previous slides, how Bridge was initially designed, it fit perfectly towards supporting a DTO system. So this also shows the vision of Bridge when we are starting. So towards addressing a safe operating space, you need a structure as such, which also supports an ideal DTO structure. So one of the main challenges was that you need a diversity of components to define the safe operating space of the Black Sea. So one application is not sufficient to address a safe operating space. So what we are launching today is a pioneering addition to the DTO framework. It's truly co-designed with stakeholders, and it addresses the ecosystem services, and it links these to different policy-related components. And it incorporates diverse components, as I said, towards addressing the safe operating space, but serves as a blueprint for advancing DTOs towards decision support tools, which a DTO should be. And as we will show you, it's developed as an editor-ready architecture, and it will connect different key data infrastructures. So this is how the portal looks when you enter the portal. So with this, I would like to launch the portal so you can access to it, the demonstrator. You can access it through the Bridge webpage, and the link will be given in the chat. But at the end, we will go in detail into the different components of the portal and describe you how it will be used. And there will be opportunities and documentations towards training, and we will have modules of showing how different components can be utilized. So the system architecture used is planned. So in a way, it's compatible with the editor architecture, but it's also user-friendly, and it addresses the stakeholder needs. So the front-end applications are developed so they can be integrated directly into the editor system. And as I said, this was not originally part of the Bridge Black Sea project, but as the DECOSYN project, as Me2, we are undertaking the responsibility of developing and maintaining this demonstrator. And this is the general overview, how you can access different scenarios. For example, outputs from different model results can be accessed through the scenario simulations of climate scenarios. You can access different variables at different depths, and even see the results for the future. And here you see the comparison of the editor structure and the Black Sea DTO structure. As I said, the two structures will be compatible to each other. So what are the next steps? We are in touch with our Mercator colleagues, which some of them are here, to integrate it into editor infrastructure. And as I said, it will be maintained by the DECOSYN. And components are already giving way to new ideas, new projects. So we are talking with different colleagues, and capacity building activities for policymakers, how the DTO will be used, will be done through different stakeholder platforms and tutorials, and this will be again maintained by me too and some of the partners here, and links towards the mission objectives will be established. So DECOSIM, the Center for Marine Ecosystems and Climate Research Center, will maintain this infrastructure. DECOSIM is MITU's main project and the center that supports our infrastructure. So it supports oceanographic cruises, a full marine science laboratory, marine observing systems that are critical for a DTO. And these feeds into the models, and these models will be supported by DECOSIM as well. So what's critical as a legacy? We need multidimensional data feeds into DTO, both in situ and through smart monitoring. Black Sea is very complicated, and Black Sea is quite a deep basin with a very complicated biogeochemical interactions, oxic-anoxic interface. For example, when we were developing our biogeochemical model, we had to redevelop many of the state equations to truly address the Black Sea dynamics. Most of the models today that are available are not truly addressing the Black Sea physical dynamics or the biogeochemical dynamics. So with Bridge, we have really carried these results to a more to a level where we have reduced the uncertainties and we have increased the confidence levels of these models. So a flow of targeted observations that can increase the confidence levels of these models are required. So we wish to continue collecting this data within the DECOSIM and find ways towards supporting the Black Sea DTO. And to achieve that, of course, we need to benefit from new sensors and tools and smart monitoring systems which are already developed within the Bridge Black Sea. And the second webinar was on that. So we wish to continue including data from gliders, scanfish, eDNA barcoding in collaboration with partners, and strengthen the Black Sea demonstrator that we are launching today. And the next upcoming event will be the Bridge Black Sea Final Conference in Brussels. And this is organized during the week of EMOTNet Conference and the Digital Ocean Forum. So I'm sure most of you or some of you will be there. So please come join our final conference, but it's in a hybrid form. So we invite all of you to join. And during this conference, we will also launch the Black Sea Bridge policy brief, which is a very strong document. So I would like to show here in 1 minute a small teaser for the Bridge Black Sea demonstrator, but the full demonstration will be made at the end of the webinar. So please stay and listen to our panelists, because our panelists will tell you what's behind this demonstrator, what are the technical aspects beyond this demonstrator, and these will be in a way small tutorials towards understanding of the demonstrator and its results. But at the end, we will give you a small tutorial on the technical aspects, how the demonstrator can be used. It's quite straightforward. Anyone, you don't need to be an expert or a researcher to use this demonstrator. Any stakeholder, any end user from the civil society, from the private, can easily utilize this demonstrator and see the results of different scenarios. And as I said, the on-demand modules are underway and the emulator is underway, and this will be also explained to you. And there are certain modules LiDAR that will be ready in a week or so. But today, the demonstrator is full and it will be fully accessible and will be maintained. And with this, I would like to now switch to the Black Sea DTO components. And with this, first, I will give the floor to Marie-Loire, who is going to talk about our modeling engine framework, the ensemble model efforts there, which is also a first for the Black Sea and which has contributed tremendously towards understanding the blue economy services of the Black Sea. So thanks a lot. So I'm very happy that we have launched the demonstrator now, which is available on the Bridge Black Sea webpage. And with this, I would like to give the floor to our panelists, which they will talk around 10 minutes each. And at the end, we will do a small showcase with the demonstrator. So please stay till the end because what you will hear from our panelists will be extremely valuable. And Marie-Laure, please.
Yeah, so thank you. So I'm Marie-Laure Grégoire
You
from the
need to switch the screens, Marie-Laure. Now we see the presenters mode.
Oh, we do not see it full screen?
No, we see the presenters mode. If you can do switch screen somewhere on the bottom right.
Okay, wait, please.
Yeah.
I know what's happened. Okay, so then, yeah.
Yeah,
Okay,
now you make it full screen.
Okay, duplicate. Yeah, that's duplicating. Yeah, okay. So you see it full screen now?
Not yet.
Yeah, but it's coming normally.
I think it's coming.
Can you see it?
Again, it's in the note. It's it says parameters.
Maybe it's slow. It's a connection.
No, it's you just have to switch your screens. It's
Or
on
just
top of.
disconnect your other screen, Marie-Laure. You are using two screens, so we see the presenters mode.
Yeah, that's strange. Okay. Okay, maybe I have to stop sharing and then I will do it properly. I'm starting again. Okay, yeah, normally it's okay. So then I share, yes. Okay, so then I share, share. Voilà. Okay, yes. Can you see it now?
No, it's the same again. Or I think it's okay if you just remove the bars on the right and the top, then at least we can see it in the still format that's readable.
Okay. Is it okay now?
Maybe you can try from the...
Yes, now it's okay.
It's okay now. Thank you very much. So then I can start. So I'm Marie-Laure Grégoire from the Liège University, and I was leading Work Package 2, which is about the development of models for making a climate projection for the bridge. So I also want to thank the Work Package co-leaders that are here from HCMR and from CNR in Italy. So the modeling framework that we have in Bridge is the following one. So here you can see in orange the model that we have developed that we have implemented in Bridge. They are in orange, and the one in green is the one that are forcing our model simulation, and the blue one are more the socioeconomic scenario that we are using, from instance, the SSP1, the SSP5, nutrient emission scenario from the literatures, and some fish scenario here that have been produced by Bridge. So you see in Work Package 2, what we did is that we ran a new atmospheric model, a regional one, for the Black Sea, which is the MAR one. We also use ocean models, which were already running in the Black Sea, the climate models, and all these models were feeding the other work package, especially work package 3 for resilience assessments, also work package 4 for making some marine spatial planning analysis, and then work package 6 for making some AI tools trying to emulate our model results. So that's mainly the frame that we have developed. So now I'm just speaking about the simulation very rapidly. So here you see the simulation that we run in work package 2. So we make historical reconstruction under different atmospheric forcing. You see, it's one forced by MPI and one forced by EC Earth, which are Earth system model. And we make projection, which you see two scenarios of projection, SSP1, SSP5, which are quite the extreme scenario that you can find. You know that already very well. SP1 is similar to the Paris Agreement, and the 8.5 is the worst case scenario. And then you move from several hundred ppm for the PCO2 to more than 1000 in the case of SSP5. So the ocean model that we were running, we have three. We have the Nemo Bambi that we are running here at the University of Liège in the frame of the Copernicus Black Sea Marine Forecasting Center for the Black Sea. We have also POM Ursum that have been run by HCMR, and Nemo Tursum that has been run by me too. All the models, all of these models, they run 400 years of simulation, each of them. And then the atmospheric model that we run here, it also runs 500 years simulation. So you imagine how much effort we had to put on the launch of simulation. Of course, we are not starting from scratch. We have already developed some model parameterization for the Black Sea, taking into account all the coupling of the physics and the complex biogeochemistry of the Black Sea, which is well known for several time now. We validate all of this model using international databases, EMOTNet, WOD, and Copernicus. But of course, I will not deter that here. I will move directly to the results. And so here you see the result, which compare the air temperature, the end of the century. So it's compared to now, what are the temperature change. You see the two scenario, SSP1, SSP5 on the right, and you see what is the temperature change if you move for the two scenario. And here is the two type of atmospheric model that we launch. You see that they quite agree here for the temperature. But in terms of increase of air temperature, you see that you move to a 4-degree increase in the case of SSP5 to about 1 degree increase in the case of SSP1. And of course, this make a lot of change for the ocean model. And so here you see all the bridge model that we have run here for the projection. And you see the different group, which is shown here. And you have here the SSP1 scenario with a trend of 0.03 degree per decade. And you see here the SSP5, for which you have a 0.4 degree per decade. So you see that we have a big change in terms of SST. And then what's the impact on the Black Sea layer, on the Black Sea physics? You see that the CIL is currently disappearing. We know that already Black Sea CIL disappearance. And for the future, we show that this CIL after 2050, so we have a lot of years where we do not have CIL anymore, and all the models run in bridge agree on these results. You have here the plot of temperature. You see here the depths, here the time, and the CIL is really the temperature value below 8 degrees. And then you see that when you move after 2050, you have no CIL in both scenarios. Then we move to the link with the ecosystem services. So we have mapped all our model results to the ecosystem service. We are able to address climate regulation. We are able to address ecosystem regulation with the biogeochemical cycle, food provisioning with the fish, and also recreational service with the plastics, for instance. So we make some case study here. So just to show you what about the climate regulation, So you see that we simulate a decrease in the pH in the two scenarios, but the amplitude of the decrease changed from 0.3 in the case of SSP5 to 0.05 in the case of SSP1. So you see here for the pH, you see here the two curve and the big difference between the scenario. You see also that, of course, the PCO2 at the surface would be completely different in the two scenarios, which is normal since the atmosphere is completely different. I remind you that in the case of SSP5, you have more than 1,000 ppm of PCO2. It has impact on the air sea flux of CO2. All the models simulate that the Black Sea remain a sink of CO2 in the future, but the intensity of this sink will decrease when we are moving to a warmer climate with a higher CO2. Then if we move to a biogeochemical cycle, we look at the oxygenated layer, and we show that in both scenarios, we are still losing oxygen, much more in the case of the SSP5, where we move from about 10% of oxygen decrease. Here we have quite a variability in the model, which is not illustrated here, but this is what we found. We can also speak about the rate, but I will not go into the details, but we show that we have an increase of the nitrification and a decrease of nitrification in parallel. Okay, now if we move to the fish, I just take here an example of the fish. And so here you have on the left the scenario of fishing that have been produced by Bridge, by World Package 6. And you see how the fishing pressure is predicted to change in the two scenarios. In SSP1, the World Package 6 deliver a decrease of the fishing pressure. In SSP5, you have an increase. What's the impact on the anchovy biomass? You see here the anchovy on the top, the sprat on the bottom. You see that in SSP1, you have a more stabilized biomass here for anchovy, but also for sprat. But in SSP5, you have a completely collapse, for instance, of the sprat biomass and also of the anchovies. Okay, now I move to the last example of the last case we have tackled in World Package 2 is the plastics. And so you see here all the pilot cells that we have in Bridge on this figure. On the bottom, you see the model simulation that show where plastic are accumulating. You see that for the microplastics, and you see that for the macroplastic. And you see the pilot cell, for instance, you see PS3, which is the Bosphorus, I guess, if I am right, where you have a huge accumulation of the plastic there. And on the right, what you see is really the impact of this plastic on the mussels. So we have a mussels model that have been developed, and here it's a kind of overlapping of the areas of accumulation of the plastics and the areas where you have these mussels. And then you see that you have some area where you have plastic accumulation and where you have a lot of mussel, a lot of individuals. Okay, and then just to finish, to illustrate, if you want to know more, we have published a lot of paper in Bridge, already 10 now. This is a very nice example of what has been achieved. If you want to know concretely what has been achieved on World Package 2, I really invite you to look at this list of paper. More are coming. And so here, for instance, we are working on a synthesis paper that will show, or maybe several papers, the results of World Package 2, and this will show the climate projection of all the model that we have developed in Bridge. Thank you very much.
Thanks, Marie-Loire. I would like to emphasize that what Marie-Loire has demonstrated are the results that are going into Demonstrator. So you can access these results in the Demonstrator, and the results of different scenarios that she has shown are mostly in the Demonstrator. So, of course, it's important that these results are also documented and published, which shows the credibility of the results that goes into a Demonstrator. but what she has shown are the different parts of the Black Sea demonstrator. And now I would like to move to the adaptive management modules, which is also part of the demonstrator. I guess the link to the demonstrator are given in the chat. I was notified that maybe there's some slowness because of too many people accessing at the same time, but please go ahead and check it out. And I would like to give the floor to Stefano, who's going to tell us about the different adaptive management modules, and some of them are cumulative effect assessment, which has developed the backbone of the marine spatial planning tool, for example, that we are utilizing, and also what has been developed here has the potential towards addressing biodiversity in the Black Sea. So it has the potential towards development of all these applications for the DTO. So yes, Stefano, please.
Okay, can you hear me?
Yeah, it's good.
Okay, perfect. Yeah, good morning to everyone. So this is exactly one of the component of the DTR demonstrator, Black Sea demonstrator, and I'm just say a couple of words about the concept of adaptive management and why it is important and why it is connected with the DTR, by the way. So we start and of course it's based on what we did in the Black Sea, what we are experimenting the application of this tool for adaptive management approach. So we start from a challenge that it is a sustainable management of complex and dynamic coastal and marine system, and we try to adopt a process that is called adaptive management, that is actually a continuous and systematic process where one learns from experiences and adjust action accordingly to what is continues to happen. So and we try within within the Bridge BS to translate the best available knowledge, especially the model that was just presented by Marie-Laure, into action, connecting science, policy, and society, because we worked a lot also with the stakeholder in the area. We use the concept of design scenario to frame and to bring together the needs that is specifically for the different use cases, and the analysis, the result of the models and the analysis, helping to build a clear and understandable narratives for policymakers. So the scenario is one of the mechanisms that we have used to combine in interdisciplinary way all the results and provide information for taking decision. And at the same time, we use one tool that is called risk-based cumulative effect assessment. That it actually the main tool that we have used to analyze scenario in a spatially explicit way, integrating data on human activities, pressure, environmental components, and included outputs of climate change projections, species distribution models, etc. And this tool is exactly the connection, provide a connection with the DTO that I will present at the end. And let's just stress on a concept that it is quite important, and is the way in which the adaptive management can be greatly benefit from the DTO, that is the feedback mechanism. The DTO should have as a core concept of the feedback mechanism between the real world and the virtual world and vice versa. And the adaptive management exactly benefit from that, because it's the way in which the planners and who have to take decision can learn about what is happening now, because he's received directly feedback from the real world. Regarding the desired scenario that we use as a main concept to imagine a future realistic state, we already described a lot in the previous webinar, the first one. let's just stress a couple of concepts here, that they are not just predictive scenarios, like, for example, the climate change, but they are also exploratives. So we try to put in this scenario what can happen if we can act in a certain way. So we can put in this scenario specific planning measures that we want to investigate in order to achieve a sustainable development and management of our area. These are the scenarios that were developed in BridgeBS. So we have three main scenarios for the three main pilot sites. So at regional scale of the Bosphorus, the Bulgarian Varna and Burgas, and the Romanian Danube Delta pilot sites, based on stakeholder interactions through the living labs. So we have co-created these scenarios. At the same time, we develop two main scenarios for future scenarios for the wide basin scale, based on the sustainable blue economy imaginaries, Ecotopia, that we call it Ecotopia, and Unity in Adversity. Within scenario, we incorporate, as said before, the climate change trends and projections, some predictive models, but also information about the trends based on, the maritime plans, local expertise, etc. Try to change and let's say, modify the activity in the areas. In parallel, as said before, we consolidate a tool for the cumulative effect assessment with two main aims. One is to tailor the analysis to case-specific needs with best available interdisciplinary knowledge, and the other is to use this tool to identify hotspots of cumulative impacts on key environmental components and ecosystem services. So the left column represents the risk-based framework that is exactly that was used exactly to clearly identify and adapt the tool to the specific context. The middle column instead represents the workflow of the cumulative effects assessment module that needs special distribution model on human uses, try to spread the pressure over the area, and then investigate the impact over the environmental components, producing some high-level outputs in terms of overall maps, graph statistics, and so on. These are the all interaction considered in the Black Sea. So, and these are the impact changes that we have considered that include 16 human uses, 21 marine strategy pressures, and 29 environmental receptors, mainly seabed habitats, but also fish species and marine mammals. We use different models to spread this pressure in terms of the nature of the pressure itself, starting from the isotropic dispersion, but also incorporating Lagrangian modeling and targeting modeling for target models, for example, for micro and microplastic. These are the models that we incorporate mainly from WP2 results, as Marilo explained. They are mainly fish biomass, but also nutrient and input of plastic. And these are an overview of the key findings that we achieve in the area. So we were able to investigate the current and the future situations of the distribution of cumulative effect assessment core map, and also investigate the differences in respect to the current situation, the right column of this map. Similarly, we achieved similarly result for the wide basin scale, and this map represents the two main scenarios of Ecotopia, Unity in Adversity, and the difference in respect to the current situation. Okay, let's now investigate the connection with the DTO. We performed this analysis consolidating our existing tool based on the tool for MSP infrastructure, a tool for cumulative effect assessment. and it is operationalized through the tool for MSP infrastructure that it is developed with the core part, the backend part, with two nodes. One is the tool for MSP geospatial repositories, where the data are stored and published. This can be discovered and accessed and visualized. And the other core part of the backend is the lightweight engine that through web API provide a mechanism to create a case study and analyze and perform the analysis for the cumulative effect assessment, but also for other tools. And then we have different front ends for data visualization, interactive mapping, but especially a decision support tool for front end. And this is the way the result of the tool that we have consolidated in this project. So this is the interface to explore the already 17 use case scenario that we developed for the Black Sea. This is an example of how we can set up an analysis, combine a different layer into a specific area, and finally run the analysis and achieve the results that are both spatially mapped, but also statistic. Then in the recent weeks, we have capitalized from this tool, providing direct feedback to the DTO, Black Sea DTO demonstrators, that especially through the tool for MSP geospatial repository, we have used these repositories to provide through interoperable services information and result into the demonstrator. And if in the future, this approach that we have adopted can be also quite quickly, we can quite quickly, and of course, sorry, the result will be presented later by the live demo that will be presenting this webinar. But of course, we can expect also a future improvement of this kind of lightweight tools engine to be incorporated directly in Edito, because it is already developed in a way that can be portable, and of course can be then this is a possible future integration in Edito, especially to support maybe example like this one, so regional DTO in the Black Sea or in the other context. So I have finished my presentation. Conclude my presentation.
Excellent. Thanks a lot, Stefano. I think this was a very good presentation showing the different adaptive management modules, the CEA, and soon we will show you how you can access to these very critical results that are showing both the effect of different ecosystem services, but also how the ecosystem components are being affected by different sectors, by different pressures. Now I would like to give the floor to Patrizio, who is going to talk about the emulator. As I told you, although the emulator is fully ready and some of the pre-calculated results are ready, it's not yet on the system, but in a few days it will be on the system, and the emulator will be able to be used as a lightweight tool, and it has the potential to be used on demand. Patrizio, please.
Yes, correct. And good morning, everyone. Yeah, I'm gonna present some of the activities we have done in Bridge in terms of emulating climate models and some of the ocean models that Marie-Laure presented before. For those of you that are not entirely familiar with emulators and what they are, it's an approximation of more complex models. It's a statistical approximation of more complex models. And the reason for that is that to reduce the complexity of these models and make them running faster. So I think it's an essential component of the digital twin of the ocean if we want to go towards the analysis of what-if scenario by a diverse group of end users, which could be policymakers, managers, and other types. So it gives the flexibility that the process-based models will not allow you to have. So what are the, in general, climate models are, of course, very important for our understanding of present-day climate, and also to have this projection of climate change under different scenarios, as it was shown before. They're very central for our understanding of the climate system in general, the Earth system. Over the time, these models have increased their complexity. They have increased the resolutions by a lot, going from hundreds of kilometers to what it is today standard tens of kilometers at most. They have a lot of interacting systems. In the Earth system context, of course, you have the atmosphere, the land, and the ocean, but only just in the ocean. We have a lot of complexity in terms of the physical, chemical, and biological processes that we need to analyze. So this complexity, of course, comes at the cost of running these models on highly specialized computers and high-performance computing, different type of GPUs, different type of parallel computing, and of course, a lot of data. These data are of the order of hundreds of more of gigabytes, terabytes of data, indeed, and it's difficult to analyze all of them. That's the reason why emulating some of these models could be a strategy to enable basically more users, less specialized users, to interact with these results. As I say, the process-based numerical simulations, they are powerful, but they're computationally intensive. So in this context, emulators could provide an efficient supplement to speed up these simulations and enable a larger investigation of explore the dynamics in a wider range of scenarios and perturbations. So the way it works is basically we use the output of the process-based model output that was shown before, and we train specialized neural network. Why neural network is because they are able to encapsulate these nonlinear dynamics that are kind of the main driver of the process model. I can hear some noise in the background. So this neural network, they are trained on the output of the process-based models, and they are, of course, tuned based on specific metrics of the how effective they are in reproducing this complexity, how much they can be trained, or they can learn the structural dependencies between the different inputs. And once the model is trained, when the neural network is trained, we can use the composition of the nodes and the weights within the nodes to understand what are the main drivers for the specific dynamics we're interested in, but also try to understand the early warning indicators of ecosystem changes and extreme events. So some of these, in terms of ecological regime shift and the ecosystem state dynamics, they are all things that have been addressed in Bridge. Here, I think I'll focus a little bit on how this engine can be integrated into the DTO. The model, the neural network is, of course, as I mentioned before, receive inputs from the process-based models. This is just a snapshot of the type of model or the type of input that we have. They are spatial and temporal dynamics across different channels, different variables for a long period, so from 1950 to 2014, and actually also up to 2100 when we did it for the different scenarios. And of course, we take different type of variables covering the physics, the biogeochemistry, and the nutrients, and the interactions between land and sea. One way to structure the network or the structure of the neural network, there are, of course, a lot of tools available out there. The specific network we have used is this encoder-decoder dynamic, which is sort of quite well fitted for sequential data. They have been used for different type of language models, but they have been used also for example, predicting the next frame in a sequence of frames coming from movies, for example. And that analogy is actually very close to what we have done, because we have a sequence of frames coming from the model simulations, and we try to predict the chlorophyll dynamic in the next time steps. We have modified the structure because, of course, we don't have a single channel. We have multiple channels, which are the different variables that we have used. So how the models perform, this is what you have on the left. You have the ground truth, which is the process model output. In the middle, you have the statistical representation, so it's the neural network forecast of that dynamic. And on the right, you have the error that we commit in using the statistical representation of those processes. Of course, the error is accumulating over time, so the longer is the prediction and the more the neural network is asked to provide a forecast, the larger will be the error. But still, it's confined, and we can actually demonstrate that within a month, the error is relatively acceptable for any kind of end user needs, especially in terms of understanding, for example, phytoplankton dynamic in different regions of the Black Sea. One interesting element that we also discovered is that, for example, if you take this one, this is the day one prediction from the neural network, and the ground truth, of course, is the real case. This gives you some increasing chlorophyll in a given area, and then the model is let free to run. So the neural network runs without any additional inputs from other sources, and still predict a bloom dynamic. So that actually gives how to say the idea that this neural network can actually have a description of these early warning indicators of ecosystem changes, as in this case. Of course, then you can scale down the predictions of the models for specific or meaningful management regions, like the one we had in Bridge. We had different pilot sites. Here you see the time series of the dynamic coming from the process-based model in blue, the predictions that we make with the neural network in red, which is very close to the blue line, as you can see. And as a baseline, we have the climatology in green. So the model actually performs quite well across all regions. But there are regional differences, not much in the dynamic maybe, but maybe in terms of drivers. And that's one of the things that actually we can analyze with the neural network, is try to understand what are the drivers at different regional space, what are the drivers now, but also what are the drivers under different type of scenarios and different type of perturbations. This is the type of output that, for example, managers could be interested in terms of understanding where should they invest more in terms of observation, or where should they invest more in terms of management of pressures. So the way we see the integration at the moment, as Barish mentioned, is not yet finalized because this emulator work in Bridge has been done in the last period, and the next step is the integration in this demonstrator of DTO. But I think the way it can be done is having this regional focus, the relevant management unit, and try to have this analysis of indicators, for example, for the present day, but maybe for different type of scenarios. And as I said, we will not be limited once the network is trained to the scenarios that we have provided by the process-based model, but we will actually be free to explore different type of perturbations in the inputs and see the response of this network to those perturbations. So in conclusions, I think emulator could be an essential tool to bridge what is the societal needs in terms of answers that they want, and the best scientific knowledge, which is encapsulated in these complex climate ocean models. I think it's very easy to integrate because although the training of the network is resource intensive, so it takes a lot of resources to train the network. But once the model is trained, to run it actually takes questions of few seconds and not a lot of resources. And that's actually what we will demonstrate in integrating it in the DTO. And I think it could be a good way to test these what-if scenarios coming from, we expect a very diverse audience of users. And of course, the visualization and the type of pressures and the type of scenarios that one wants to test should be discussed with specific users. But I think that the tool is very flexible to address all of it. So I'll stop it here, and thank you all.
Excellent, Patricio. This was really good. As Patricio has explained, I don't have much to add, but this will be one highly needed and a strong tool for the DTOs. And now I would like to switch to the resilience analysis module, and Susa will explain what's in the background of this module. Again, this is a pioneering work that was done in Bridge, and resilience assessment, especially with utilizing model results, is one of the first attempts. And you can see these results at the Black Sea demonstrator at the demonstrator at the moment. Yes, Susa. I think you
Sorry, are we having the same issue then with Mary Lorna?
No, it's all
you-
okay.
It's all
Go ahead,
okay.
Susa. Yeah.
Okay, because I see it very strangely. So okay. So good afternoon to everybody. Did it change or are you okay still?
It's still full screen,
It's
all
still
good.
okay.
Yeah,
That's
go ahead.
great. Okay, so good afternoon to everybody. My name is Susanne Iranen and I come from the Stockholm Resilience Center at Stockholm University. So we are going even a bit further north than with Patricio in Denmark. And I'm going to tell you a bit about the resilience assessment we did in the Bridge Black Sea project and also how resilience assessment is being incorporated into the Bridge DTO. And this is actually the work that we have been doing, or Ali has mainly been doing during the past week or so. So I'm super excited myself as well. So if we talk about the resilience within the Bridge, we assess the resilience of the Black Sea social ecological system because we want to identify under which conditions the provisioning of ecosystem services as well as the maintaining the social safe operating space can be compromised or it can be maintained. And with resilience, we use this very classical definition that we refer to systems' ability to retain its essential functions, structures, and feedbacks. And this means when faced with external stress, such as climate change, for example. And if the system is resilient, it kind of implies this kind of degree of predictability. And this makes resilience often a key characteristic that's valued, for example, by managers. So we often want to avoid these unexpected surprises when we are managing a system. Then a loss of resilience, it can result in severe changes in ecosystems. And we have seen this actually in the Black Sea case very clearly. And that was changed in the end of 1980s, early 1990s, when the Black Sea went from planktivorous fish into a jellyfish-dominated system. So in this sense, Black Sea is actually a very good example to study these kind of resilience dynamics. And we can't do this in every system either. So this is really the textbook case. And when this kind of change happened, so it was really what happened was this, that we ended up with a system like the below one here. You had a lot of jellyfish everywhere. And it was not a result of a single driver, but a multiple drivers. So it was the fishing that had happened before. It was the jellyfish introduced to the system, as well as then other environmental factors. And of course, top-down trophic cascades. So now that we have assessed the resilience in the Bridge, we have used something called integrated resilience assessment method. This was introduced by Vasilakopoulos a couple of years back. And this method, it's quantitative and it uses long-term data. So we need to have long-term data from ecosystem components and we need to have long-term data from ecosystem stressors. And it's three kind of key things we can assess with this kind of assessment. So we can identify key system stressors and their relationship with the system state. We choose what the system state is that we want to look into. We assess tipping points and thresholds, and we can quantify relative resilience of a system. And we can also visualize this resilience in a stressor state landscapes. And these are the kind of things that we want to import into the DTO. And what you see here is an example from real Black Sea data. And if you take a look at the colorful picture on the right-hand side, I don't know, do you see my pointer? No? Yes? No? Okay.
We see your cursor.
Yeah,
so-
you do. Okay, that's
Yeah.
good. So you see on the x-axis, we have environmental stressors. This could be individual stressor, or it could be a compilation of different stressors, like sea surface temperature, climate indices, nutrients. On the y-axis, it's system state. So we can compile different ecosystem component time series here and see how the system state has changed. So it's description of the ecosystem in this case. And when we go, we have two different states we have identified, 1990, 2005, it's the lower state here. And then 2006, 2020, it's the upper state. So we could, in this case, it's actually a better environmental state is the upper state. And how you read these graphs, you go from you follow the line. When the stressors are reduced, you get to the first tipping point, which is the F1 here. And after that, the system changes onto the second state. So you can say that in this case, there has been kind of a recovery. And once again, when the years go by, the environmental stresses decrease, you get higher up on this state. And when you have the green color, we have higher resilience. It's further away from the tipping points. When we have the red color, we have lower resilience. And this means that during these years, under those conditions, environmental conditions and the state conditions, the system is more vulnerable to environmental stressors, such as climate or fishing, for example. So then what we did in Bridge, often we look into things at the basin scale. And that's also what has been done previously when we look into the resilience of the Black Sea. But now we want to look a bit what happens when we go into the pilot sites. And now we've looked into fish landings across the different EEZs. And why fish landings? It's first of all, catch is often fish landings, or catch is a metric that we often get from statistics. And as Parish already said, we don't have so much data from the Black Sea. The second case is that, or reason is that it's socio-ecological variable. So it's affected both by the socioeconomic conditions like changes in technology, markets, as well as the environmental conditions, which is the stock and how that's controlled. But when we looked into these different fish landings from 1960 to 2020, we saw that actually across the different EEZs that you see on this graph, we had temporal changes in both the volume of the catch or landings as well as the composition of this catch. And we could see that these changes were not similar across the different EEZs, which would warrant an EEZ-specific resilience assessment. So what you see in the DTO also now is that we look into the resilience dynamics of fisheries across the different EEZs separately. And we want to look what is the current resilience situation when it comes to the fisheries or the landings. And how we do this, we carried out this full integrated resilience assessment. We use the EEZ-specific fish landings as our state variable, a combined variable. And we used key stressors as the stressor. And this means now sea surface temperature and different climate indices, as well as fishing effort that we have. And what we then include in the DTO that Ali is going to show you, we first of all include time series of resilience index. You see it on the right-hand side here. The higher the bar, the higher the resilience in time. Now the time's on the x-axis. This is the case of Bulgarian EEZ. You see that there has been a shift in the 1980s and the resilience has gone down before that. Current situation is that the resilience has been quite high, but there are certain years when it actually does take a dive. And this is the same type of graph that I showed you as an example. But this time you go from the highest state, the stressors increase, and your system flips into the lowest state. And then where we currently are is the red circle here. We see that the conditions are not that stable. So currently it seems that if there would be some environmental stressor or some other perturbation of the system is vulnerable to that. So that is what you can say about these figures. What we also do then, and this is even newer things that we've been doing, but you saw the presentation by Mary-Laure, where the model outputs for the different future climate scenarios were presented. And we know now that the system has changed quite drastically in the past, but we also then, we would maybe expect in that case that these kind of changes would also happen in the future, and that's what we want to look into. And now, of course, we are very lucky because we have all the model results from the different SSPs. In this case, we've looked into the SSP1 and SSP5 output, and for the years 2020 and 2100, using the output from METU's low trophic level model Nemotourism, as well as the fish model Osmos. And what we have done here is we have once again carried out the full integrated resilience assessment. We use the state variables as the low trophic level biomasses that come from the Nemotourism model, and then the fish biomasses from the Osmos model. So we really now, the system state is the ecosystem state in a way. And then we use as a stressors, we use now, once again, climate variables like SST or salinity, oxygen, and nutrients, but these are extracted now from the outputs of the nemotourism low trophic level or biogeochemical model. And what we get, this is just a teaser of the preliminary results we have. We still need to do a lot of testing, but what it would show now is that we also do see these kind of threshold events in the future. We have identified one around 2045, 2050, change of state. But I would assume also we will identify another one around 2080. So this is something we need to still work statistically a bit more with. But the vision now for the DTO, at least from my side, is that we can actually carry out these resilience assessments on the future projections on the model outputs that we already have in the DTO. There's a lot of things we need to do. There's a lot of statistical analysis included, and we need to verify these analyses. But I think we are well on the way of doing this. And I think that's what's pretty exciting with this part. So as a conclusion, the resilience, it really is a measure that combines information from various ecosystem components into a single metric that indicates of this kind of ecosystem or social ecological system state. It can also give you an idea of the safe operating space. And then to calculate this kind of resilience index, you can't do it in every system in every case, but you really need to have this kind of two different ecosystem states that you know that the system flips in between. There could be even more. And this has to be observed in the data, and you need to know that these mechanisms exist. And you also need to know what is driving the system. Otherwise, you can't do this. And Black Sea, of course, I'm very excited that this is now being part of the DTO of the Black Sea, because historically, this is one of the systems where we have seen these dynamics the most clearly. And then there is the note that as there is a number of statistical tests we need to carry out, then we can't necessarily run this automatically, but we really need to analyze very carefully what we put into the DTO. And we are doing this, and we are doing that currently. So that's all from me. Thank you very much.
Thanks a lot, Susa. This was quite clear. It's the resilience analysis results is one of the results which is hardest to follow, of course, but Susa is trying to make them as simple as possible. So thank you, Susa, for that. But it's a very critical analysis if we are talking about the safe operating space. And now I would like to switch to Alice, and switching to the socioeconomic data and the socioeconomic observatory. I'm sure Alice will say that, but what she will show is also a very strong module of the Black Sea DTO, and the University of Athens has already kindly offered to maintain it for the next few years. So Alice, please go ahead.
Thank you very much. Good afternoon, everybody. Are you seeing my presentation in full screen?
No.
Not yet.
No, that's what I thought. Okay, I'm starting sharing. Right here. Sorry about that. Switch this. All right, so yeah, good afternoon, everybody. So I'm Alice Guittard. I'm from the Athens University of Economic and Business. And as Baruch has mentioned, I will present the Black Sea Blue Economy Observatory that we have been developing as part of the Bridge Black Sea project in parallel of the Black Sea DTO. But just a little bit of context why we need such observatory.
Alice, sorry,
yeah.
We don't see your screen yet.
Oh, you don't see my screen?
No.
Why not? Sorry about that.
We see, yeah.
Alice, I'm just going to share it for you.
No, it's okay. No, I'm sharing it. Okay, so you should see it now, right?
Yes, not in full screen.
Yes, now in full screen.
Yeah. So I was saying just a little bit of context why we need such observatory. So the blue economy has been experienced a dramatic increase of exploitation of marine resource and marine space, which is often referred as the blue acceleration. And of course, this exponential growth has been not without any consequences on the marine environment, with like dramatic increase of pollutions and negative impact on marine ecosystem and marine habitat. So due to this unsustainable use of marine resources, we really do need a strong, measurable sustainability framework to ensure that the blue economy and the blue sectors are actually developing in a sustainable way. So we do not want just economic indicators, but we want social indicators and environmental indicators to ensure that we have an economic growth that is socially equitable and environmentally viable. So very quickly, there is still some challenges in relation to having this kind of like sustainability framework. So if we look at the international level, there is some frameworks such as the Agenda 2030 with the AGG 14 related to ocean. There is also this ocean index that is providing some kind of like holistic framework for measuring the blue economy, but it's still like a bit scattered. So we did this kind of benchmark and trying to identify and choose some relevant indicators, not only from the economic aspect, which of course has been challenging, more specifically for the Black Sea. But so the Blue Economy Observatory, first of all, for the Black Sea is based on the very good example of the European Blue Economy Observatory. So we use this kind of framework to develop the own observatory for the Black Sea, which include not only the European countries of Romania and Bulgaria, but the other countries that are not yet represented in the European Blue Economy Observatory, since they are outside of the EU. So what is this Black Sea Blue Economy Observatory? So we have 4 different sections. A dashboard that is providing indicators in order to monitor the blue economy sectors per countries, and there it's essentially providing a visualization of a set of data, capturing, at least trying to capture at this stage, economic, environmental, and social aspect of the Black Sea blue sectors. So we have a sector sections that provide detailed information on the current status and development of the various sectors of the blue economy in the region. We have also a dedicated section on the scenario and roadmap, where we provide a snapshot of the different scenarios, blue economy scenarios that have been developed within the Bridge Black Sea project. So such as the scenarios that Stefano presented earlier on the desired scenarios. And finally, we also have like a marine policy and financial sections that is still under construction, but here we expect to provide like overall information in terms of key policy framework that are applied in the Black Sea region, as well as potential financial information and funds of instruments that can be mobilized by the Black Sea stakeholders. So looking a little bit more in details on what is exactly this blue economy dashboard. So we have like so the overall idea of this page really is it's about to provide visualization of the data and access of those data. We don't necessarily make analysis, but we really like brought all the data that we could have access to from the different countries. On a specific sector. So within the platform, you can filter the data per sector. So here it's coastal and maritime tourism. We can filter the data per country. We provide information of where we found those data, because again, we do not produce data, but like we gather data from other sources and we bring it there. So here you have the exact information on when the data have been downloaded and where. Also, those data can be downloaded here, and in terms of visualization, so yeah, once you have like a more specific information on the data, And this graph is also showing the different data that we have per countries. And also the idea there is to also highlight the data that we do not have actually. So any kind of countries that is not represented in the graph is actually showcasing that we couldn't manage to have free access of those specific data. And finally, you can also filter by different type of indicators. So in terms of the sector section, so here it's pretty much in the same example actually as the European Blue Economy Observatory. So this dedicated sector section, you have dedicated page for each of the sectors that are currently operating in the Black Sea region, and within each of those sections you have an overall a view of the status at the regional level of these specific sectors, and also you can click on each of the flag and you have the specific status of these countries for this sector. And the third section, so on the desired scenario. So here the idea is really to provide a snapshot of those future scenarios for the blue economy, and that have been developed by within the Bridge Black Sea project. And it also allows to directly download the full report of each of the scenarios. But here the reasoning behind the sections is to provide a snapshot, essentially not only but like really for policymakers to give them an overview of what could be the potential of the blue economy in the future, depending on different decisions. So in terms of what are we at for this specific tool, so really the main purpose of the Black Sea Blue Economy Observatory is, so as I mentioned, so it aims at monitoring the sustainable development of the different sectors within the region, but really to have this kind of like one-stop shop of Black Sea socioeconomic data, considering that at the moment most of those data are scattered across different database, sectoral database, but also country, national statistical institute websites. So here we were trying to bring everything in one place. So it informs about the data availability currently in the different blue economy sectors. And also through this work, we are trying to highlighting the remaining gaps in terms of data availability and also data collections. So at the end, also this tool, this observatory is aimed at providing an overview of like snapshot of potential future development for the blue economy in the region. And finally, so in terms of remaining challenge to further develop the observatory and making it a key decision support tools for decision makers, but also for private sectors, is that we still not have a universal set of indicators that can fully cover the full spectrum of sustainability. So this like lack of holistic and shared common framework is a bit of a challenge still at this stage. So that means that we still do not have data for many of potential sustainability indicators. So either those data do not exist or they are not freely accessible. In the Black Sea particularly, we still encounter this lack of harmonization in terms of monitoring framework. And as I mentioned before, it is scattered across organizations and not always publicly and freely available. So also through this work, we're trying to highlight the real need to have an harmonized regional data collection and an open access policy and framework. So in relation to the Black Sea DTO, so the Blue Economy Observatory is one of the modules as part of the full digital twin of the ocean for the region. However, we are still working on how to further integrate the socioeconomic data within the mapping visualization capacity of the Black Sea DTO. So it's still work under progress, and behind this also, of course, there is this further reflection that needs to happen in terms of how to better integrate socioeconomic data in the overall digital twin of the ocean. And that's it from my side. Thank you very much.
Thanks, Alice, for this. And with this, we end presenting you the different modules of the DTO. Now, we would like to go towards demonstration of the demonstrator, the DTO demonstrator. So we will basically give you a tour and show you how the demonstrator works. As I said, it's very fast and user-friendly. As you have seen, the data and the work behind each module, it was critical to show the work behind each module, and it was tedious work in many respects. And of course, the uncertainties and the confidence levels were critical, and all these are reported now as part of Bridge. So now I would like to give the floor to Ali, who is going to showcase the demonstrator. We'll give you a small tour. And then if you have questions or any comments, we can further discuss.
Hi, everyone. I'm Ali, and I'm working on the physics biogeochemistry coupled models in MET2. And I'm going to show you the DTO system that we designed here. Let me share it full screen. So this is the landing page. And I think Barish covered the DTO concept very well. So I can just go straight into the components listed here. So we have several components right now active, and components that we are working on is, here passively shown. And we can quickly go over the first component here, explore physics and biogeochemistry. But before that, maybe we should note that these two components, first one and the second one, creates a core engine that can feed the other components with the results. I mean, the first component produces physics and biogeochemistry results, and based on this, you can compute the fish biomass, and these two can provide information to resilience and the CEA and the AI-based ecosystem emulator, and all of them here, all the components at the end will go into the data services where you can access the data directly. Not only the model data, but also the stations, the CTD measurements, observations directly from the collected in the Bridge BES, and also the historical data set from MET2 services. So let's go over the first component quickly. So those who were in the General Assembly had seen this before, but right now we have a new a feature called compare here, comparison mode. I will show you right now, but let's go over quickly what we have here. On the right side, we have a panel that shows the available models. Right now, these models are ready, but we're implementing them to the system right now. And we have a depth slider here, which you can make the depth slicing when the map is active. And there are some variables here, physics and biogeochemistry variables. On the left panel, we have climate scenarios, and there are the hindcast, SSP1 and SSP5 future projections, and the comparison toggle button. And the lower left side shows the time slider, which you can play with. And so let's pick a variable, and I can show you how dynamically you can check the Black Seas, for example, deep layers. As we all know, deep Black Seas anoxic, so there is a transition point roughly around 110 meters. So if you go here, and so if you play with time scale, you can track down how the oxygenated layer is decreasing in time. So all three models we produced here predicting a slight decrease for the oxygenated layer depth. So you can track down each variable that we present here with time and depth layers, which is very important, I think. And we can pick the chlorophyll, for example, and we can again play with the depth, or you can play with the time slider. You can pick one of the projections and you can check what will happen in the end of the century. But the most important part is, stakeholders will ask the question, okay, we know the current status, but what will happen under different scenarios? So we developed a comparison button here. When you click it, it will split the screen into two parts. So the left part shows the worst case scenario, and the right part shows the best case scenario right now. And also the depth slicing is active right now, and you can play with it. Let's go to 40 meters maybe. And let's go to until the end. Let's move the time slider to the end of the century to see how different is the models predicts under different projections. So if you play with the slider right now, you will see this surface is updating itself with different projection scenarios. So this is very effective to see any part of the Black Sea. And you can also zoom into the basin to see high resolution changes as well. So, so this is basically the first component capabilities. And there's a learn more button, which we will update this with the details of the models also. And there is a river load scenario here, which is the first thing that we will want to do for on-demand runs. So we will allow users to play with this river load scenario, and under these climate projections, what will happen in the future, they will observe and explore actively here. So this is all from the first component. So let's go to the second component. The second component is higher trophic level and the plastics. So when you go into the component, you will see the distribution of the fish biomass. We have fish biomass and yield and the plastics. And there is a selection bar here, which you can change the metric to biomass to the yield, or you can change the species available here from the list. And this will update the common name and the file drawings here for this specific species. And you can play with the elevation bars. And so if you want to see the detail, you can zoom in. And if you go over the bars, you will see the values and the units also. And this shows yearly fish biomass, for example. You can track down with time here. And if you switch back to the plastics, and we have two options here, macro and micro, and they are monthly covered. So you can play with the time series, and you can play with the elevation scale to see how they accumulate across the basin. And so the second component looks like this, and we have the scenarios for this module also. I mean the future scenarios, but right now we're in the process to implement them. So there's a learn more button again, and it's pretty much explaining how the system works here. So we can go to the third component, the resilience assessment. Susa mentioned about these landscapes and the time series, but on the left side, on the top left side, there's a learn more button. So it shows the details of the system to you. And then you can pick a region. Right now, Bulgaria and Ukraine is active. So if you switch them, this EEZ will update, shows you where it's calculated actually. And if you can go switch back to the Ukraine. So yeah, this landscape is active right now. You can see the resilience scores when you move your cursor. And yeah, as Susa mentioned, if you're getting closer to these tipping points, actually you're losing the resilience. And the red corresponds to low resilience here, and the high blue values are high resilience actually. So below this landscape plot, we have a time series here, which the higher the bar and shows the higher resilience. And if you click one of the bars, there is a point pops up here and showing where you are exactly right now. So after these tipping points, a gentle trend usually suggests a recovery, but yeah, we need to be careful here because it's only acceptable if the stressors are in the favorable way. So it's really difficult to build an automatic way to show the resilience. So we need experts to analyze this detail and summarize the results for us. So on the right side panel, there's an information text box which covers the most important parts about these plots. And if you change the region, then it will update this information immediately, as you can see. And it shows you the regime shift years, which is shown as red dashed line here. So I can move to the next component right now. Cumulative effect assessment. Stefano mentioned about the scenarios available and the pilot sites. So our design consideration here, I mean, each component, to answer the question, what's the current status and the future scenarios. So we want to show the difference of these different scenarios. So what we designed here, we designed 3 maps. One of them shows the baseline, one of them shows the scenario and the difference between them. So you can individually pick one of these maps, but from the baseline, they are also synchronized. So if you move this baseline map, you will find a synchronized view. So you can zoom in and see the difference of the cumulative effect here scores, I mean CEA scores. So you can set the color bar max to highlight a specific region also. Also, you can change the difference maps color bars as well. So you can also pick different scenarios from here, and the text box on the left explains what that scenarios actually are. And there is an ecotopia and unity in adversity, which Stefano mentioned these scenarios. And on the right side, there is a text box which summarizes the results simply. And the Learn More button is always to show the details of the system here. So yeah, this is about the cumulative effect assessment system we have. I will give the floor Alice to explain, but at the end I will give the floor to Alice to explain the Blue Economy Observatory part. But let's explore the other components right now. So we have AI-based ecosystem emulator, which Patricio shared the details. Right now, we have a working emulator, but we are in the process to make it available on the server side as well, because we wanna employ these on-demand runs. We wanna allow to users to create their own scenarios and see the results immediately. And there is the Jupyter Lab component, which you can make some analysis, and this is very effective when you want to make calculations on a near data environment. So you don't need to install anything with Jupyter Lab. You need only a browser, and you will be able to analyze the data directly. So on the last component is the trainings and tutorials. We will add as much as we can. I mean, we will add videos, we will add step-by-step guides to to teach people how they can use effectively this DTO system. But the last component is the data services. Let's go into this. And on the right side, it shows the bridge BS stations, the CTDs and the data collected from the bridge project. And if you click one of the stations, it shows the metadata to you, and you can go check what's available and the dates and other information. And also, there is a button of bridge layers and the DECOSYM stations here. So if you click the DECOSYM stations, you will see the historical data sets of database of the METU. And the DECOSYM is a national project here, hosted at METU. And yeah, so you can switch between the bridge layers and the DECOSYM stations also. On the left side, there are model results, which we allow users to interact with the direct REST API links. So right now it's accessible. The model results are accessible. So you can go and pick these, copy this REST API, and you can visualize them actually. With this option. And you can also, because this list is, going to get larger and larger because we have a lot of model results. So there is a search button. If you, for example, if you're looking at a specific variable like nitrate, it will filter the files that contains nitrate. So yeah. So right now, I think this is all from the DTO system. I can give the floor to Alice to show the Blue Economy Observatory as well. Thank you.
Thank you, Ali. And I think Alice will access herself to a demonstrator. Yeah.
Exactly. Thanks a lot, Ali. Thanks, Barry. So very briefly, in order to allow time for questions. So since I presented already the platform, but as you can see, so once you enter the platform, you have like the 4 different sections, and here we also added like a brief numbers, like country facts on the different countries of the Black Sea. So if you go to the dashboard, so you can choose like between the different sectors that are implemented in the Black Sea. So not all of them have data, but if we go to capture fisheries, so this is how it looks. So I also want to insist that it's still a work in progress. So we continuing like improving the platform, adding more data and making it more visually friendly. So then you can also like select specific countries, as I mentioned before. You can select specific years, for instance. But what is quite important is that, so here you have, it gives you information on where those data come from, and more particularly, so you can download those data. So if you look at the sector section, as I mentioned, so you can click in like all the different sectors. So if we look at capture fisheries, so we have an overall presentation of the status of the sector. So essentially those information, they come from different work that happened during the bridge Black Sea project. We always like put the sources and the date. So then you have like you can click in the flag and you have specific information per country. And if you look at the scenarios, for instance, if we look at the desired scenarios, so the one that Stefano presented before. So here, so we have like a bit more information on each of the scenarios per what we call pilot site in the bridge project. So you can look at different specific images, and you can have access to more in-depth information so that redirect to some specific part of the report. But what is very important is, as I mentioned before, it's still a work in progress. So we are like really more than happy to get feedback on the platform, and potentially if you are aware of like additional data that are not yet present and visualized in in the platform. So please let us know, fill in this contact form, and any kind of feedback is really good for us. So we are keep working on it constantly and trying to make it a better tool for policy decision making and supporting the monitoring of the Black Sea sectors. And as I mentioned also, we will in the near future try to better integrate it to the platform of the Black Sea DTO. And I will give you back the floor so that we can have some Q&A if any.
Yeah.
Thank you very much.
Thank you, Alice. This was very good. We are almost perfectly on time. So this is the end of what we would be presenting. So as you have seen, I would like to again underline that all these modules are interlinked and feeding each other. And also addressing a safe operating space is extremely complicated. You need to address many different indicators, aspects, and you definitely need to have a big engine behind supporting these and a big data inventory. And the analysis that was presented here will be added to the system in terms of tutorials, but also we will carry out trainings towards different levels of stakeholders and end users. But as you have seen, the system is extremely user-friendly and very fast, despite the data load behind it. So feel free to utilize it and feel free to reach us with your questions. But as Ali has shown, there is sufficient material, reading material, accompanied with the results that are being shown here. But trainings and tutorials will also be available. But we think this is a very critical step towards a Black Sea DTO. So we are very happy to have launched it today. So if there are any questions, I can take the questions. Otherwise, we will close our third webinar session. And yes, Nicolas, it's great to see Nicolas from European, but you can introduce yourself, Nicolas, please.
Thank you, Baris. Yes, Nicolas Segebart from the European Commission in DG Research and Innovation, and I'm responsible for ocean observing and the digital twin ocean in particular. First of all, congratulations to you and to all your consortium. You clearly put a very intense amount of work into this project, probably also integrating activities beyond it. So that is very much appreciated. I think the strength of European projects lies in their adaptability. And I think you have demonstrated that with the effort that you have done to align with the landscape, which has indeed evolved since your project was funded. I was curious and checked in the initial grant agreement whether DTO or digital twins were mentioned, and it's not. So you clearly show that you were flexible and that you could adapt it. You could adapt to a landscape which is evolving very rapidly. So that is very good. You talked about portability towards Edito. So it's very good that you already started working on that. But I imagine that there is still a lot of work to do to make that possible and happen. And for that, I'm very pleased to be able to say that there will be opportunities already next year. And you may already know it because I hinted it at Baris, but it's also publicly available. There will be a specific call under the Mission Ocean for the development of regional components for the EU DTO. So that is to integrate existing assets and further develop them into Edito. So I see here a huge opportunity for this work to be integrated together with other activities. I was in the meeting of the Doors project recently, and they also have very interesting developments which may be useful for integration into Edito. a key aspect of Edito, as I see it, is that one of the difficulties that we systematically face, or almost systematically face, with European projects to have very good output, but output that require maintenance or further support over time, is that the support is not always there. And I see that there's a commitment from partners here to maintain the system after bridge actually finishes, but it's still short term. And so Edito brings at least the infrastructure that allows the maintenance by actors. Now, in addition to the technical challenge to integrate what you have been doing, but I'm very optimistic because you already thought about it, it's how can your efforts be reproduced or used for other sea basins, and how to integrate with the general tools and assets that will be available under Edito, taking into account that you may have very different types of users, from the scientist who should know what they're doing with the outputs of project and of what will be available, and then other types of users that require very strong and validated information. So that is an aspect that will need to be considered for the soon future. And then one point on the Alice guitar presentation. It's very interesting that you work on the socioeconomic data and how to integrate that into digital twin approaches, because eventually this is the ultimate goal, right? It's to be able to balance decisions in terms of socioeconomic needs and impact on the environment in a changing landscape, and to be sure that we have investments which are durable, that we don't throw a big investment to the bin because of whatever happens in 2 years' time that we could have predicted. There are four projects who are working on socio-ecological models. And I think it would be very interesting to have a common approach to how to deal with socioeconomic data and how to integrate them into digital twin approaches and into the EU DTO. So I recommend that you reach out to them. I know that they have joint activities. Maybe you're even part of one of the consortium, I don't know, because there's very similar to what I heard in other settings. But definitely there's an opportunity there also for you.
I take note. And I know some, not me personally, but some of my partners that I'm pretty close with are like part of those consortiums. So actually it will be quite easy to reach out to them. And yeah, I will do so. That's a really good idea, actually.
So thank you all, and congratulations again for the impressive amount of work.
Thanks a lot, Nicholas, first of all, for being here and for your very motivating words. We are extremely happy to hear that and extremely happy to see that you appreciate what's being done and encouraging us for further work and recognizing the potential. We definitely would like to build up on what has been done here.
If I manage to find it, I will put the link to the draft mission work program in the chat here for everybody in case you don't have it, because it's not easy to access or to find.
Thanks, that's also appreciated. And I would like to give the floor to Antonio
Hi.
From DG Mare. Hi, Antonio.
Yes, hi, Antonio Guarnieri. I worked a lot with Nicolas. I'm from DG Mare 1, so Marine Knowledge. So thanks a lot for the demonstrator. It's impressive. I was really impressed because it's rather holistic. You display the chain that starts from physical issues, physical modeling. It goes much beyond, which is what the DTO wants, as well as socioeconomic data, socio-ecological, and all this. So my questions and comments a bit overlap with those of Nicolas, actually. He already told you about the future possibility of conveying all this and plug into the DTO. I think this would be absolute to the European DTO. This would be absolutely important. And my question was if you have already thought how to do this, also on a scientific and technical point of view. And another thing is, you have mentioned a lot, and this is very good, the stakeholders asking for future scenarios. You provided a lot of scenarios, but once they will have the scenarios, there will be a problem of understanding the quality of this scenario and the reliability of this scenario. If you have thought about this, or because it probably cannot just be the tag of the fact that this is a frontier research, so we can always rely to that. There must be also a quality process that make them more reliable. And once we achieve this, how do we need to ensure the sustainability of this over time, of the quality and of all these applications and result, and that's going to be difficult. So it's important that we already start reflecting on how to do this, and if you have already started thinking on how to ensure sustainability of quality of the work. So these were comments / questions, and I renovate my congratulations because it was very impressive. Thank you.
Yes, Antonio, very relevant questions, but also hard questions. First of all, in terms of integrating to Edito, we are in touch with our colleagues from Mercator. So we are working on that. And also how we have designed and established the Black Sea DTO. Yes, as you can see here, the technicalities behind it is compatible with the Edito system. So yes, work is required, but we are confident that we can have it on the Edito system within a short amount of time. We are ready to undertake this work. Although, as Nicolas has already explained, this was not part of our grant agreement, but and in terms of maintaining, MITU takes the responsibility of maintaining this as part of the DECOSYN project. That's how we have undertaken this work of developing this demonstrator, and maintenance wise, even supporting it with further data wise, MITU and several partners from the bridge project will continue. Of course, we will need funding. We need funding in terms of confidence levels, for example, you have mentioned. And these are challenges that are also raised in the call that Nicolas has shared now. So increasing the confidence levels are definitely the next steps we need to pay close attention to. And there is a lot of work to be done, but hopefully with the new calls and also with the in-house support that we can provide, we will carry it to the levels that will be much more impactful, and the confidence levels are high. But again, I appreciate your comments and being here and recognizing the potential of our work. Very much appreciated.
Thanks to you.
Okay. I don't see any other questions, but if there are any comments, it's welcome. But I think comments by Nicolas and Antonio were extremely valuable and summarized where we are and has shown us the potential next steps. So we will definitely take up on that. So if there are no comments, I would like to close this, our third webinar session. And the turnout rate was really high, highly appreciated your presence here. And I would like to thank everyone. And don't forget that as Bridge, we still have our final conference in Brussels. Please keep following us. And yeah, don't hesitate to reach out to us. Best wishes and see you all. I would like to thank all the panelists and to everyone, to all my colleagues and to all the contributors and to everyone that has registered and joined. And Gonzalo is here. Thanks, Gonzalo. Okay. Bye, everyone.
Thank you.
Bye.
Bye.
Thank you.
Bye. It was great. Thank you.
Bye-bye.
Thank you very much.
Bye.
Good.
Thank you.
Bye.
Bye-bye.
Thank you.